again and again it will become in the pillars. Yeah. Yes. And along with that comes some microorganisms. Those will be also available as a deposits like foraminifera, radiolarian, arthropods, diatoms, and other pollen and spores, which are extensively used to determining the relative different ages of different rock formations. And this round we discussed yesterday, and today we are going to discussing about the geophysical methods. The geophysical instruments which are helps in the measurement of a certain physical properties of a rock subsurface within the earth. And it's involved the field measurements like gravity, magnetism, seismicity, and electrical resistivity of a different rock formations with using of a different sensitive instruments. The data collection of a lithological characters of a rock formations, and it can be used in a stratigraphic classification, and it's a useful to study of a correlation. Suppose example for if you see the electrical logging, it's a useful to find out the electrical resistivity of a rock, and gamma ray logging it's a useful for to find out the radioactivity of a different rock formations. And again, the main purpose of these rock studies, it's a speaking and the investigation will be carrying out on a stratigraphic investigation, stratigraphical sequences. The special instruments which are allowed in the boreholes and which are used for record the changes in the physical properties of the same rock formation within the earth. The paleomagnetism, if you can see, in your paleomagnetism, it is also very important tool to study the stratigraphic correlation of Cenozoic rock formations. Yes, it is known as the position of the Earth's magnetism, and it's speaking the changes of polarity. Yeah. Yeah, it's known as the position of the Earth magnetism, and it has been changing the polarity over a period of geological time. The Earth is consisting of both igneous and sedimentary rock terrains, and these rock terrains it's retain the magnetic minerals. And these magnetic minerals we can identify with using of this paleomagnetic processes. Correlation, that's also we have seen. The correlation is speaking about the speaking about the relationship between the two factors, the relationship between the two characters. It's aimed to matching the rock formations of different areas, whether the deposited in the same stage of Earth evolution study or not. It's a saying about that. So that such two formations are deposited at the same time, it is called as a homotaxia. That means here, at the same time, the two formations were deposited. And if the two formations, if not in the same time, it is indicating as a synchronous origin. It is called as a synchronous horizon. A standard stratigraphical scale is required to establishing the correlation rock succession of different regions of different ages. Yeah, now let us see the standard stratigraphic units. Yeah, the Earth scientists, their opinion, the age of Earth or the Earth, it was born before the 4.6 billion years ago. Yes, since that onwards, the Earth is getting the different experienced in a geological events. Yeah, those events which are recorded in the formation of a rocks or in the pages of Earth history. So that the rock sequence which were deposited during the certain duration of a geological time or a geological period, and it's which contain the characteristics of fossil, it's constitute the chronostratigraphic or time stratigraphic units. Yeah, it's a chronostratigraphic means that it's related to the chronology. The stratigraphic formations are layers or the rock beds which are related with the age. The chronostratigraphic unit, it is divided into the systems and systems into the series and series into the stages into the zones. And as well as the geological time scale also, or geological time, it is also divided into the periods, periods into epochs, epochs into the ages, ages into the phases. Yeah, the standard chronostratigraphic scale is not made suitable for stratigraphic divisions of unfossiliferous data. There are some limitations in a new scheme of a classification of rock succession and it's proposed, known as a lithostratigraphic unit or a rock stratigraphic unit. Yeah, this type of a classification also follow the same basic principles of a stratigraphic classification and correlation. And here we'll see the chronostratigraphic units, and it similar to that lithostratigraphic units of a time. Here it's mentioned the first one, it is geological time units. In a second column, it was mentioned as a chronostratigraphic units, and third one it is a lithostratigraphic units. We see the as according to the examples. In a geological time units, era, the unit we are calling here, it is a era, and the example will say that is a Cenozoic era. It belongs to the Cenozoic era. If you go into the periods, in a period, that's a tertiary period and epoch. We see that is a Miocene epoch. Age, it's a Ponanian age. Phase, Globorotalia phase and Tumida Fluxovsa phase. The same, if you compare with the second one, that's a chronostratigraphic units. The unit is Cenozoic era. It's equivalent to the Erathem, and there is no mention in a lithostratigraphic in unit. Same chronostratigraphic units, the system you see here is equivalent to the period of geological time, and it's equal to the lithostratigraphic unit, that is as a group. The system, it's an example here you see, that is a tertiary system. And similarly, we see that series, stage, zone. Series is equal to the epoch, and stage equal to the age, and zone it is equal to the phase of a geological time. Else, we go into the lithostratigraphic unit. In a lithostratigraphic unit, its group it is equal to the period, formation it is equal to the period, epoch member it is equivalent to the age, and bed it is equivalent to the phase. Yeah. Coming to the geological time scale, the successive arrangement of a standard geological standard stratigraphic and time units as a standard reference for worldwide correlation. It's known as a standard stratigraphic scale and geological time scale. The wider stratigraphic unit, that is erathems, systems, and series, are readily recognized in most part of the world, and hence a single set of nomenclature for these units is used by the stratigraphers throughout the world. Yeah, if you see that is an erathem, it's representing as a succession by a succession of a rock formation and deposited during an era is a record of the broadest division of Earth's history. An erathem is generally made up three or more systems. A system constitutes a part of an erathem, and it is represented by a succession of rocks which were deposited during a period. In a Phanerozoic rock formation, system is characterized by the typical fossil assemblages. It means different ages or different areas which are having different formations. Yeah, we see from bottom onwards of a geological time scale. Yeah, it's a Precambrian. Precambrian era. The first column it is known as era, and second column it is a period or a system. Third column it is a epoch or a series, and fourth one it is approximately of years. Yeah. If you see the Paleozoic era or the Precambrian era. In a Precambrian era, it's Archaeozoic or Archeans, and when you come into the periods and the formation of the crust, it was started, or formation of Earth, it was started before the formation of Earth. The age was approximately around the 4,000 billion years, and this is about 4,600 million years. Yeah. And next, there was no life. There was no life here, and then slowly we step into the proterozoic, and the proterozoic again it is divided into the three periods. One it is a lower, second one it is a middle, third one is upper. In a lower age, it was started from the 3,500 million years to the up to 3,200 million years. The first sedimentary rocks were formed. After the formation, again we see the oceans and the continents. The lower period or a lower proterozoic period, and again we go into the 3,200 million years. The first stromatolites and anaerobic bacteria was discovered, or the first stromatolites or anaerobic bacteria was formed. Then the middle proterozoic. In the middle proterozoic, we see the age around the 2,500 million years to approximately 1,600 million years. And there, between this is 600 to 1,600 to 2,000 million years, the atmosphere is consisting of again a slowly development of oxygen and marine algae. The slowly development of marine algae we see, and the first microscopic algae was developed. And yeah, slowly, if you come down to the Paleozoic era, in the Paleozoic era, the periods are divided into the five. The first one, it is Ordovician. Ordovician is two types ages. One, it is early, and second one, it is a late. In early age, it's a formed, or the age it belongs to the 500 million years, and it's consisting of abundance of trilobites, graptolites, rise of cephalopods. And Silurian, if we go into the Silurian, it has a 430 to 440 million years. Graptolites disappeared slowly. The graptolites were disappeared, and first fishes were started in the Silurian age. That's around 430 million years to 440 million years. And Devonian. In Devonian, it's divided into the three early, middle, late, and the age was 395 million years. It has abundance of corals, brachiopods, and appearance of land plants. And earliest known, the amphibians also, they were developed here. Carboniferous. In a Carboniferous, it has a early Mississippian and late Mississippian. And in early Mississippian, it's around 345 million years age it has, and the glass after is flora, it's a dominated area, and the late Pennsylvanian, that's around the 320 million years, and it has many non-flowering plants. Permian, if you come into the Permian, it's early, middle, late, and the age it was around the 280 million years, and it has a primitive reptiles and last of trilobites. Mesozoic. In a Mesozoic era, we see that it's a Triassic, Jurassic, Cretaceous ages, and these epochs are series consisting of early Triassic. It's consisting of a three, early, middle, and late. The age was 230 million years. And again, it contains ammonites, reptiles, and amphibians are abundant here. In the Jurassic age, about 190 to 195 million years. Here, the fast birds, flowering plants, and flying reptiles, including dinosaurs, were developed. And coming into the Cretaceous period, in a Cretaceous period, it has two series. One, it is early Neocomine. The second one is a late Sinonian. And the age, it is around 136 million years. The last of dinosaurs and last of ammonites. And it's a rise of flowering plants. Yeah, Cenozoic or Cainozoic, it's divided into the two periods or two systems. One, it is a tertiary, and the tertiary again divided into the two systems. One, it is a Paleocene. Second one, it is an Eocene. In the Paleocene, again, it's consisting of a series. One Paleocene, second one Eocene, third one it is a Oligocene. The age around 64 to 65 million years, and it has a first placental mammals, whales, apes. Again, it's having a flowering plants. the tertiary age. In a tertiary period, in quaternary period, we see the Holocene and Pleistocene. The age around about 1.6 million age, and it has living animals. Man appear here. Many mammals die of during the glacial period. Yeah, this is about geological time scale. And how do we know that absolute age of rocks? The absolute age of Earth, and it's consisting of different rock formations, and we can determine by various methods, such as the rate of sedimentation, and the rate of increase in a salinity of sea, and the rate of biological evolution. These are all the facts. These are all the facts we'll be working when, these are all the facts we should consider when we are determining the age of different rocks. Yeah, recently a reliable and widely used method has been developed on the basis of radioactivity decay. Yeah, the science which measures the age of rock, minerals, water, and biological materials is based primarily on the radioactive decay. It's called as a geochronology. We are calling that is as a geochronology. The radioactive elements constantly undergo a process of decay to the formation of a stable isotopes. The radioactive elements constantly undergo the process of decay to formation of stable isotopes of radioactive decay. It's spontaneous and not affected by any physical parameters like temperature and other pressure, all those things. And it's giving the accurately information. And each radioactive element reduces the half of the quantity by decay at a period of its time. It's known as the half-life period of elements. The half-life period of each radioactive element, it can be measured in the laboratory and with sophisticated instruments. How we can identify the radioactive elements with a longer period of half-life? It's used as a geochronology of Precambrian rocks. The most commonly used elements for dating Precambrian rocks are uranium, thorium, rubidium, and potassium. Uranium and thorium decay to form a stable isotope. Lead and alpha particles minerals having more than 1% uranium and thorium, such as uraninite and monazite, zircon, and alunite are used for dating. The sedimentary rocks containing glauconite, ilmenite, etc., and igneous rocks having the potassium feldspar and mica, which are suitable minerals for dating of rocks. Rubidium strontium method, it is a very important method, and it's widely using because rubidium, which occurs as a trace element in alkali feldspars and in mica. And again, one more, it is a carbon dating. It's also very important method to applicable to younger rock formations. And the ratios are calculated from plant remains, which are enclosed the younger sedimentary formations. Yeah. The radiometric method of a dating of these rocks have become, it's a very essential tool in Precambrian stratigraphy. The Precambrian rocks are generally affected or repeated cycles of technonism and metamorphism. Because it's impacted by these two processes. These rocks containing the radioactive elements, maybe it's dispersed and migrated into the distant areas. So that in the use of that samarium and its daughter elements, neodymium isotopes are used for determining the absolute ages of very old rocks. The samarium and neodymium elements are not affected by any metamorphic process. So that these elements are very important, or these isotopes are very important to study the absolute age of older rocks. Yeah, coming to the physiographic divisions of India. Physiographic India is almost expression. It's a total geological structure, and it's a lithology. And the Indian subcontinent is broadly divided into the three well-defined regions. One, it is a triangular plateau of peninsular India. Second one, it is a extra-peninsular India, inclusion of a milestone regions. And third one, it is a plain area of a Indo-Gangetic alluvial plains. The peninsular India has rocks and it's covering the older to the younger formations. In ancient plateau, it was exposed for a long time, denudation resulting in a penetration. And the mountains are of object related to the type. It rivers are traverse for the most part comparatively flat of a country with a low gradient and have a built shallow, broad valleys. And the extra peninsular India is consisting of a part of alpine and Himalayan tertiary mountain belt, and it has a region of a folded and overthrust mountain chains. It is a rivers or a youthful or actually eroding the beds in their course and causing out the deep and the steep sided gorges. And one more thing, it is Indo-Gangetic plains are broad. The mountains level expenses build up to the recent alluvium through which rivers flows towards the seas. The plains were originally a great trough between the peninsular and extra-peninsular regions. And the origin and the structure are very closely related to the rise of the Himalayas. Yeah, peninsular India. The peninsular shield, it is characterized by varying the physiographic graphics and association of plateau mountains, where with widely distributed drainage, peneplain, and it has an ancient foothold and maintains, and it has a batholith formations, and it has a graben-like valleys, and also inclusion of coastal plains. The peninsula exposed in four regions have distinctively different structural geomorphological trends. The southern part of Western Ghats, with north-northeast, north-northwest, north-northeast, and the south-southwest and south-southeast. And eastern Ghats, we see that's the northeast, southwest, Satpura, Mahadeva ranges in central India, including with the trend of east and west. The Aravalli ranges of northwestern peninsula with a northeast, southwest trend. And of course, the chief mountains of the peninsula India are eastern and western Ghats. An elongated graben, its valleys, peninsula, Narmada, Son, Damodar, valleys trending east, west, and Mahanadi and Godavari valleys, which are flown northwest and southeast trend. the eastern Ghats. The eastern Ghats forms a series of a rather, and maybe it is a detached the hill ranges, and it has a heterogeneous composition, and it is extend from the border of Orissa through the coastal region of Andhra Pradesh. Yeah, now this is a physiographic of you see this. This is you see this is a physiography of our Indian continent, Indian subcontinent. Yeah, along this Orissa and coastal border of Andhra Pradesh, coastal border of Andhra Pradesh, Orissa and coastal border of Andhra Pradesh, to the joining of Nilgiris in Tamil Nadu. The average elevation height is about 800 meters, but at some places like Mahendragiri, Shivaroy in Salem, and Niyamgiri, it's a Koraput rises to 1500 meters. So 1650 meters and 1550 meters are we'll see nearby the Koraput areas. The eastern Ghats meet western Ghats at Doddabetta in Nilgiri Hills. Eastern Ghats are mainly consist of condolites, charnokites, micotites, and gneisses. Yeah. Yeah, as well as we see the Western Ghats. The Western Ghats constitute the ranges of a mountain called Sahyadri, which are extended almost north-south and parallel to the west coast of India. The mountains are running from Tapti Valley in the north down to South Cape Camorian. And again, in the northern part, we see the Dharwar formations in Karnataka and Ratnagiri. And nearby area, it is a Mumbai. It's a composition composed of Deccan troughs, while the southern parts consist of Archinices, cyst, and Charnokites. And next one, it is Vindhyan Mountain, and we'll continue tomorrow. I'm stopping here.